just way along, isn't it? Then that becomes a different, more like a clip.
Yeah. Just flop it over.
Flop it over if you like.
Yeah, that's the smartest way.
I think we're going to go a fair way before.
One of the most successful inheritance.
On the Israel.
No. They probably fell off something, so.
Yeah. We'll get there.
Hold on.
Yeah,
The
the whole
idea
week.
came around from the Japanese bridge building, Glen Gardens, and then from Sydney Harbour Bridge as well. Archers trying to spread the weight over two places, with no support in the middle. Truss techniques, and
Why don't you show
then
the
two ties.
picture? Because that was really good.
I can show you the process of build if you want. Have a
It's quite interesting.
together.
Are you counting how many?
You can go.
I think that one makes it six.
You've got more on Tommy's side.
There are more there.
That's one.
7.
7.
7.5.
Oh, kilo.
You could be the first ones to use all the paper. 8. You might as well put the weights on as well.
Yeah. Is that made out of metal?
I think you can give them a roll for the money. They'll weigh more.
9.
Is this going to be 10k?
In the middle, don't you?
Yeah, well, in the middle, you've got 5. It's 5.
There
10k?
you go.
Now they're getting nervous. Nervous off the one.
Feather top. 11. Yeah, Alex, you might as well fly over it. That's cool. You've got loads more weight behind you.
Bloody hell. It's quite impressive.
I don't see how it looks unless it's plastic. Unless it holds up in No. Have you run on paper yet? Should you send me weight? Oh, tempting fate. It's all done one thing to weight. If you start lapping it closer to the middle.
Where do you want
Really see the edge. You've got to make it.
So here, right? Yeah, put them there.
Are those
500 grams.
0.5, so it's another kilo.
What is that altogether?
When we get to the end, like walk across
It's either
it.
14 or 14 and a half.
What's the highest that's been done on this exercise?
Wait.
They have used,
Oh, did
but
they?
they've got to the end as well. They've used all the paper, but I think I've got slightly less
They are
paper.
1 kilo.
Is that another 1 kilo? As in 16k.
Bloody hell.
Just mind your feet when the weights fall off.
Because it bounces. Yeah, I think that's what we've got to be in there actually. Just that cage truss underneath the weight.
I think this is the maximum.
I think the kilo on top in the
Yeah.
centre might crack it.
Yeah.
These are the
But they're going to try and push it on the sides, I think.
Are they halves?
These are 1 kilo.
They're one.
One in the middle for fairness. One in the middle.
You're going to run out of weight.
How many kilos? Wow. I estimated 30, so I don't think
Alex
you're
is
there.
really estimated. Come on, Alex. Go on.
Won't stop.
Come on, Alex. Don't stop. Together.
$1 kilo.
2 more.
It's 20, is it? Yeah, keep your feet away when you...
Yeah.
Go on, stick it on. Stick it on. 18. Zoe on.
Whoa.
That's well.
1 kilo. You haven't got any more, do you?
It might slip. It's going to slip.
Is that 20 or
Slip.
22?
It's because the pile's tilted towards us.
Yeah.
Oh, yeah.
I would say sit
Yeah.
down.
It's going to fall. Mind your feet. Mind your feet. Mind your feet. Mind your feet. Mind your feet.
Yeah, come away from it.
Mind your feet. It's going to fall this way.
Yeah.
Your
It will.
As if I knew! Now, that's what we say. Everything should break at once.
Thank you.
Yeah.
Well, up till I know you.
20
Hi guys. Good actually keep it right down because we're teaching in the other section. It's always a problem.
No, we couldn't hear earlier.
Yeah, there
No, I
was
totally
lots of...
understand. So
Rich kept.
Did your man come back?
Tommy, how do you feel?
I love it.
You did well, man.
Can I ask many questions?
Yeah, we're yes, we are. Before you go.
Sorry.
How did you go about the design process? Who was the primary design person? Okay.
Yeah. The main goal is that there's no vertical business support, central guide to great weight. And that's meters each level about 20 mil. So yeah, it's join both of them together. End on end, it's not working with staggered joints. We go one beam, we've got staggered across the end, so doing 4 stages, that's what special is. We use 2 central beams, like 2 arcs, or have supported weight onto it, and weights as well. So then we've got 2 main arches, then we've got tight underneath, forming the string. So we center parts together, clamped it and formed it tight up into the same across the string. Then we have the bottom parts, the thorns, when you it's not there anymore.
Yes, it's gone.
Use the tie the arches in with the string sticking away. Then help spread the weight even further. Tie the each end. And the arches connect in the middle. Any downward pressure will form a TP support structure. And it just helps spread the weight more. Basically straight like that, then you get a typical size. Not always, but most of the time.
Can I ask a question about the team? What was subjective to this about team? Can you two tell me a little bit about are there any things you wish had been done differently about the way your team works?
Oh, but the teamwork or towards
About the whole project? About how you two contribute?
oh, me. Oh, okay. How what?
Getting here today?
Yeah, what I definitely we moved into the last part of actually explaining what could have been done there, linking to what's on the floor. We could make it stronger and more actually going to an in-depth contribution. Generating more.
And what was your proudest contribution to the team?
But do you realise what you were actually doing in the event was pre-tension?
Yes.
Yeah? Fantastic. So that's a huge delight for you. Really fantastic to see. And also that you incorporated caution steers into those really important. I've seen the previous fail because not because they weren't strong enough, but because they just turned.
Yeah.
That was fantastic, really good to see. And while I was trying to read these things, I picked up that some point in the presentation that thermal expansion was desirable. Ms. Moss mentioned it at some point. There's quite a few issues with movement of materials, movement of construction, movement generally. Yeah, exactly.
I had the same question.
Yeah, exactly. So, yeah, so you just hit that number one and maybe
I mean, sorry, I would say a classic example of plastics expanding and causing a problem. If you've got plastic black, particularly plastic guttering, and the sun comes out, and you're laying in bed on a Sunday morning, it's creaking and creaking, and it's horrible. Plastic expands. Okay? Okay, thanks.
Our material is steel. My name's Sam. This is Nabu. Firstly, what is steel? Steel is an iron alloy, control level of carbon between 0 and 1.7 carbon. Steel is used extremely widely in all types of structures due to its relatively low cost, high strength to weight ratio and speed of construction, which is important when you're on site and you want to get the job done within the time scale. Steel is weak in fires and must be protected in most buildings. Despite this high strength to weight ratio, steel buildings have as much thermal mass as similar concrete buildings. Now, stainless steel is an iron carbon alloy with a minimum of 10.5% chromium content. There are different types of stainless steel containing different proportions of iron, carbon, molybdenum, nickel, and it has similar structural properties to steel, although strength varies significantly. It is rarely used for primary structure and more for architectural finishes and building planning. It is highly resistant to corrosion and staining.
The advantage of steel, as you can see, steel is everywhere, all buildings constructed. And as we're here in Greenwich University, you can see everywhere, you can see steel everywhere. So now let's just talk about steel. Steel is very strong with both 10 products and 5 products. They have and steel is usually used assembly relatively quickly. The disadvantage of to use steel. Steel is expensive compared to concrete and wood. And steel can rust when exposed to some environmental conditions, including soil strength. Steel is every material including I look at the span of the land management considering for use as a building.
Then we have to ask, is it durable and safe? Thanks to exceptional resistance to fire, corrosion and pests, steel framed buildings are the first choice for extreme environmental conditions. Steel doesn't need treating with pesticides. Preservatives or glues is also safe for people handling, living or working around it.
I want to explain something due to the bridge itself. There's been something happened this morning due to
Hold on, the others. Carry on, go on.
Get to that.
Save it.
What is it?
Next, we have to ask if it's sustainable, which a lot of companies in the modern era will be asking when they work, who's got on their company to use sustainable materials in what they're doing. So is it environmentally friendly? Steel framing lasts longer and is light and easy to transport and creates minimal raw material waste. At the end of its long life, steel can also be fully recycled and reused. So it's been used for 10 or so years and the building's being demolished or taken out and take out and use it for another project or even a smaller project to keep the building going. Sustainability is structural steel as a middleman. Structural steel is the most recycled material on our planet. Today's structural steel is made 88% recycled product. It's fully recyclable in the future and can be reused without further processing. Is it fire resistant? Steel frame housing components have been tested and proven to withstand severe bushfire temperatures of more than 1,000 degrees centigrade. As you can see by the picture, it won't feed a fire, so if you're looking to one of the buildings that's fire resistant, then steel is an ideal product. Steel in construction, other materials may be able to start field work sooner on site, but the rapid design, fabrication and cycle with structural steel will allow the framing system to finish sooner and be available earlier to other trades. Today, when competing framing systems are evaluated for projects using comparable current costs, structural steel remains the cost leader for the majority of construction projects. Comparative studies indicate that a structural steel framing system includes decking and fire protection will typically cost 5% to 7% less than the concrete framing system on a national basis. All other materials talk about high strength, but their strength is still less than that of a structural steel, even when enhanced by steel reinforcing. In fact, the increase in the standard strength of steel used in buildings today compared to 10 years ago is greater than the total strength of competing high strength materials. And here you can see just a few of the forms. There's the steel block, the steel beam, and the steel sheet. So it can be in all different shapes and sizes. Here's an example of just the steel structure used in construction. During the beginning of the project when the building is first thing goes up, and here are our references. Now time to test the bridge.
Before I test the bridge, I just want to say something. As I was saying earlier, something happened this morning. It's not exactly what it's supposed to be, but it does qualify for its IBS weight. So at least we can try this one out, hopefully.
It's a Plan B bridge.
Plan C.
Basically,
Plan C.
They had an accident in the car and it was split off. So.
There was a lot of road rage.
Do you want to weigh it first?
I like it.
Yes. Briefly. 107. Nice line, man. 107.
Should go for it, right? Let's just keep it. Because we can get a lot more.
Plan D then.
More. Yeah. No, I don't know.
It's done.
Hey, what's that? 1.5.
Yeah, the opposite.
Yeah, that is the last one, isn't it?
Did you have something else, or was that it? I thought you were looking for another presentation.
No, I was just-
That's it, okay. If you've got questions for
Okay,
those
questions
guys?
then, please, gentlemen. Okay, tell us about how the team planned and tested their bridge.
Well, we had a couple of sketches earlier. We went for a Warren type bridge. We thought it would be the strongest. And we focused in on the foundation, which was the strongest point first. And we thought it best to keep it separate and we joined it for the presentation itself. Didn't go according to plan. Other than that, they had potential. We decided to went for it. But
Where was the inspiration? Where did you source examples of it?
well, this has worked, I could say that. I looked for the strongest ones. But Warren bridges were coming up quite frequently, so I thought we got the chance to Warren.
Okay, how did you split your time between you though? Did one of you build it, or did you build it together? Or?
We split up initially, I was on the material presentation,
Right.
and it was between on the bridge movement and sort of between both. Today, obviously had Max and Swan, so we had to sort of jump on it, trying to get something. So yeah, it was the bridge we had.
Before was
Before
good,
was
yeah.
much
Better.
thicker and sturdier than.
So the original was Trust Bridge,
Oh, yeah.
probably would have done originally.
The stadium was in Swansea now. I'm not so unhappy with it.
Type of steel to study, or was it the best performing steel in a category? Is it more type of steel like that you previously got?
Yes. Well, when I was researching the presentation, that's what I was generalised with the steel itself, just then found stainless steel. And what I was looking more to is the construction, so when you're on site and how's it used on site. That's why I showed this steel frame. So I was trying to pretty much like link it towards the sort of link it to when you're on site and building sites and how they can use it, especially the durability as well when they're recycling it. So it's a material that can be reused and
The type of steel that are used in large quantities.
You mentioned stainless steel, and you said it's impervious. It's always stainless. Is that actually correct, do you think?
Thinking back on it now, I would say so. No.
Now that I've asked the question
Yeah.
in such a way.
I would say so.
Yeah. You have to be very careful when you specify stainless steel because some are very susceptible to certain types of corrosion. And you will often see the wrong stainless steel specified in swimming pools. for instance, and it corrodes very badly. You had a couple of points about steel in fire, and I think you actually contradicted yourself somewhere. At one point you said it has to be protected, you have to be very careful. Another place you said it's fireproof.
Yeah.
Which is, I mean,
I know.
it's hard to set fire to
Yeah,
steel,
yeah.
that's true. But you realise. Do you know what happens to steel? What's the problem with steel in fire?
Expands.
Well, it does do that. There's a bigger problem.
Spreads. Not the state what the steel said.
Yeah, steel, just structural steel. As in,
Heats up. Heats up.
yeah, and then what happens? Okay, I won't push you. I mean, effectively, it loses its stiffness. It bends. Yeah, so it doesn't burn. It doesn't need to. It will collapse. I mean, the classic example, of course, is the Twin Towers. The collapse there. Unprotected steel reach temperatures and a building falls like a car. So it's why we have to make sure that we protect steel. Sometimes by encasing it in concrete, which is often done. Sometimes in domestic properties with the plasterboard, specified 2 layers of plasterboard around the wall. Okay, thank you very much.
Okay, thank you for your contributions. Thank you for eventually endeavouring not to phone your mate, phone a friend, read your phone, because that is hugely distracting and incredibly rude. And it's not nice when you're presenting, so you should not do it to other people. I think there's quite obviously a winning team. However, the marks are not just on the weighing of the bridge. The ultimate marks are relevant to the aesthetics of the bridge and the quality of your presentation. However, I'm going to give your judges the floor individually. Each of them are going to take a couple of minutes just to give you a resume as to how they think you performed. They've all undertaken this exercise themselves over the years. They've seen a complete mix of bridge designs, bridge failures, successes. So I'd be quite interested to know where they think you sit on a scale of success this year. Do you want to start, Richard?
Yeah, okay. For my sins,
You may have to stand up.
I do have to stand. You know, I'm not good at that anymore. Can't stand, can't hear, can't see very well.
That's to their advantage, probably.
The joys of old age. Yeah, Christine's right. I think I've probably been doing this exercise for the best part of 15 years. Maybe a bit
When
more.
someone said to me last week, could I make this simpler? It's this man's fault. It's largely his exercise.
Yeah,
It's largely,
I think
I've amended it, made it slightly more difficult, thrown in the materials.
Yeah.
Inherently, it's Richard's
Yeah,
task.
no, I'm sorry about that. Okay, well, overall, I think you seem to do a good job. You came up with some interesting designs. I like to see a little bit more variability. As Christine said, there was one that was kind of outstandingly different to the others and clearly did well, been well thought about. One of the things we've found over the years of doing this is that a lot of the strength of the bridge, the ability to take the loads that are required, actually comes not from a really fantastic design, but actually from well constructed bridge overall. So something that's actually been carried out carefully. The joints cut properly and glued properly. It makes a lot of difference. The other thing is, Ben mentioned this, that it's the flexibility of a bridge. Your bridge was very stiff, didn't tend to fall over to one side. Torsionally, it was a stiff bridge. You had actually triangulated in that direction, which helped that considerably. Also, the base was reasonably broad, so it couldn't topple over. So that's something you have to look at. We didn't actually specify in this brief that you had to be able to pass something through this bridge. We call it a bridge, but actually you don't have to pass something through it. You don't have to drive a train or a car through it. You could triangulate all the way along that bridge, effectively make it a beam, and that would make it a very torsionally stiff bridge, and it would probably take much more load if you make the joints really well. So, you know, they're just a few points about that. I mean, you might do this again one day, and you might remember those things. You've also learned that you have to be careful transporting it here. It doesn't matter how good your bridge is when you build it and when you've got it in your car. If you break it on the way here, there's nothing we can do. You're not the first to do it, whoever it was that broke their bridge on the way here. We did have a few years ago, someone had brought their bridge in their car and brought it out, and the wind blew and slammed the door on their bridge and smashed it to pieces. But they tried to recover, and you tried to recover, and that's always a good thing. You've got to do your best to make the most of it. So overall, you know, that was good. I think, you know, if I think back, you did quite well. Most of the bridges were not stupidly heavy. No one just glued a load of sticks together to make a thick plank, which would have been, you know...
They tried.
Well, you may have tried. I didn't know that, and I don't want to know that. So you all had a good attempt at doing it, and that's the important thing. I hope you learned something from it, because actually, of course, that's the object of the exercise. Do some research, find out some stuff, and hopefully learn. You should have learned to work together a bit as well. I suspect not all of you did, but hopefully most of you did. Working together as groups, and maybe with people you've never worked with before, maybe never going to work with again, that's important. When you get out into the industry, you all have to work with people. I have to work with Christy. You know, I mean, worse still,
That's why Richard retired.
She has to work with me, which is... so, you know, you have to work with everyone, and it's good to learn how to do that here. If I can say just a couple of points about presentations. You did reasonably well at that, some very well. You need to speak up when you're doing presentations. You know, speak in your outdoor voice, speak loud, because here it's even worse because there's other people around. But at any presentation, if you're talking to people, particularly in business, maybe you're trying to get a job, get someone to give you money, you need to be confident, stand up there and speak. Don't read from a piece of paper. A lot of you did that. You must not. Learn what you're going to talk about. And appear, even if you don't know it, appear to understand it all. Be absolutely confident. That's how I've got away with life in the last 40 years. More, probably. I know nothing about anything. So speak up, be clear. Don't read from notes. Don't put too much on your slides. Some of you had too much on your slides. I was sitting there trying to read 20 lines of slide. You're trying to talk to me. I want a couple of bullet points here. The bullet points are up. I can see your headings, and then you can talk to me with confidence. Expand on what you've said on the slides. That's the way to do it. Gives a much better impression. Sounds like you really know what you're talking about, and it's easier for me to follow. I've probably said enough. Okay.
Very desperate to say something.
There'll be nothing left.
Oh, I'm only going to say one minute's worth of stuff. For me, this was actually a better set of presentations than I'd experienced before. So I disagree with you just from the volume.